The next topic we're going to take is factorial notation. Factorial notation is going to be really important in counting. For any integer n factorial, for any positive integer n factorial, and we write n factorial, by the way, it's just a mathematical operation, represents the product of all positive integers up to and including n. So n factorial means n times n minus 1 times n minus 2 times all the way down to 1. Now, that's probably not very useful to you. We're just going to spit out a definition right away. And that definition is 0 factorial is 1. Otherwise, this factorial business just won't work. So evaluate the following numbers given in factorial notation. Now, your calculator should have or will have a factorial, and it will be an exclamation mark. So I'm going to evaluate the following numbers given in factorial notation. 4 factorial. Now, what does 4 factorial mean? It means that you start at 4 and you multiply the integer that is 1 less, which is 3, and then you multiply it by 2, and then you multiply by 1. So 4 factorial here, I believe 4 times 3 is 12 times 2 is 24. So 4 factorial is 24. Now, the next one I'm going to do is 6 factorial. Now, 6 factorial is 6. I'm going to start off, that's our starting place. And then you just decrease your integer by 1 until you get down to 1. Times 4, times 3, times 2, times 1. And when you do 6 times 5 times 4 times 3 times 2 times 1, it is 720. Please, I encourage you to try to find the factorial button in your calculator. 0 factorial. What? Oh, you have to use the definition. So by definition, 0 factorial is just 1. Now, 13 factorial. Well, 13 factorial means 13 times 12 times 11 10. This is going to be a while. So naturally, that's what it means, by the way. Times 9, times 8, times 7, times 6, times 5, times 4, and then eventually you'll get down to 3, 2, 1. And if I type in 13 factorial, it is a really big number. I believe it's 6,227,020,800. So these factorials really explode quickly. So 13 factorial is a very large number. Now, take a look at the way that I wrote it here. I've tried to resemble it so that it looks like up there. At a certain point, you kind of get tired of writing your factors n, and then the number 1 less, the number 2 less than n, and then you're like, I'm tired, and then finally 3, 2, 1. All right. So factorial notation can be used to shorten the fundamental counting principle when all items in a set are being used or arranged in a particular order. So, how many ways can 7 students be seated in a row? So 7 students, I'm just going to call them 1, 2, 3, student 4, student 5, student 6, student 7. So they might have names, but I'm just going to number them 1 through 7. And I'm going to ask myself, well, how many choices do I have to make? Well, if I'm going to put them in a row, one, 2, 3, 4, 5, 6, I need to have 7 seats in a row. And I'm going to just visualize 7 seats in a row, and I have to make a choice. I'm going to choose who goes in the first. How many options do I have? 7 for that first choice. How many options for the second choice? 6. right? So 7 and then 6. And then there are 5 left for the third seat, right? And then I'm going to put somebody in the middle, so there's only 4 people left. Now, I'm going to put somebody in this in that seat, so that is 3 options. There's 2 seats remaining opening, so I'm going to put one of the 2 people remaining. So, and then there's only, in the last seat, there's only one option that I can have, person 3. So I'm just going to put 1. Maybe I should have called that A, B, C, D, E. Maybe I should use letters. Anyways, when I multiply this out, there are 5,040 ways to arrange 7 people in a row. I could write this in factorial notation just by saying 7 factorial. Now, example 2. I like example 2 better than example 1 because they give you the word question. Now, I'm going to do something unusual. I'm just going to write the letters to question backwards. I find that I'm really less likely to make a mistake when I have letters to organize rather than a word to organize. This is nonsense to me. But how many different ways, and it helps me see, well, how many different letters are in question? There are 8 letters. So how many different arrangements of all the letters question are possible? And arrangements, they are just sort of like in a row. Sometimes they're called different words, but it's a mathematical word. So I'm just going to put 8 blanks here. So 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 choices. So how many options for my first choice? Yeah, I have 8. And then I used E, say for example, and then I'm going to place another letter in that second place. I'm going to put O there. But I had 7 choices. And then I go back. I'm going to make a decision about the third place, but I have 6 letters left, so I'm just going to maybe put a Q there. It doesn't really matter. So I had 6 choices. The next one, there's 5 choices remaining. And then 4. And then 3. And then 2. Last but not least, there's 1. So this is better. If you notice, I'm taking all of my elements and I'm going to arrange them in an order. Like I'm using all of them. So this is done 8 factorial ways. And when I do 8 factorial, it is 40,320. So factorial notation is very important in counting. It's kind of weird to get used to it though. Just stick with it.